For centuries, humanity has gazed at the stars, wondering if we could one day travel beyond our home planet. Now, standing on the edge of a new era, Mars, the red planet, beckons us. This is the story of our journey from Earth to Mars and the first steps toward becoming an interplanetary species. Why Mars? Among all the celestial bodies in our solar system, Mars is the most Earth-like. With a thin atmosphere, frozen water, and a day length similar to our own, it presents the best chance for a second home. Scientists believe Mars once had flowing rivers and vast oceans. Could it support life once more? Moreover, Mars has resources that could one day support a human colony, from its rich mineral deposits to the potential for underground water reservoirs. But reaching Mars is no small feat. It's a staggering 225 million kilometers away on average, a journey lasting anywhere from 6 to 9 months. Astronauts will face intense radiation, extreme isolation, and the challenge of surviving in a completely alien environment. The vast distance also means that real-time communication with Earth is impossible. Messages take anywhere from 5 to 20 minutes to reach Mars, making quick decision-making crucial for survival. Traditional chemical rockets, like NASA's Space Launch System and SpaceX's Starship, are our primary means of transport. Starship, developed by SpaceX, promises to be a game-changer, fully reusable, capable of carrying over 100 tons of cargo, and designed to refuel in orbit. But future missions may explore more advanced propulsion systems, such as nuclear thermal propulsion or even ion drives, which could dramatically shorten the journey time and improve efficiency. This spacecraft will lift off from Earth, rendezvous with an orbital refueling station, and then begin its interplanetary cruise to Mars. But what will life be like for the crew during the journey? The long voyage to Mars will test the limits of human endurance. Astronauts will live in confined spaces, recycle water and air, and maintain their health through rigorous exercise. Psychological resilience will be crucial as they endure months of isolation with only their crewmates for company. Additionally, they will need to perform scientific experiments, monitor their spacecraft systems, and ensure they are fully prepared for their arrival. Could artificial gravity, perhaps created by rotating spacecraft, one day help reduce the adverse effects of weightlessness? Once at Mars, the next great challenge begins: landing safely. Unlike Earth, Mars has a thin atmosphere, making traditional parachutes ineffective for large payloads. Engineers have devised solutions like retro-propulsive landings, heat shields, and even supersonic parachutes to slow descent. Another key consideration is the landing site. Scientists are carefully selecting locations with access to water ice and relatively stable terrain. The first landing spots will likely be near the equator, where temperatures are less extreme and solar power is more reliable. Starship is designed to land vertically, using its powerful engines to slow its descent. Once on the surface, the astronauts will emerge to take their first steps on an alien world. But survival will not be easy. Mars is a harsh world. Freezing temperatures, dust storms, and unbreathable air mean every resource must be carefully managed. The first habitats will likely be inflatable modules or underground bases, offering protection from radiation. Scientists are also exploring the idea of 3D printed habitats made from Martian regolith. These shelters must also be insulated against the planet's extreme temperature swings. Future designs might even incorporate underground lava tubes, which provide natural shielding from radiation and meteorite impacts. To survive long-term, colonists must use what Mars has to offer. Water can be extracted from ice deposits and underground reservoirs. Oxygen can be generated from the Martian atmosphere, which is 95% carbon dioxide. Food production will rely on hydroponics and possibly underground greenhouses. Scientists are also exploring the potential of genetically modified crops that can withstand Martian conditions, as well as microbes that could help convert Martian soil into fertile ground. The first Mars colony will be a testament to human ingenuity, built on the determination of pioneers willing to endure the most extreme conditions. A world unlike Earth, harsh, barren, yet full of potential. Scientists, engineers, and visionaries will come together to transform Mars from a hostile wasteland into a home. Energy will be the lifeline of the colony. Massive solar farms will harvest power from the sun, but dust storms that can last for weeks pose a serious challenge. Scientists are exploring nuclear power as a backup, ensuring a stable energy source even in the harshest conditions. AI-driven robots will play a crucial role in construction, using advanced 3D printing techniques to build habitats from Martian soil, known as regolith. These structures will provide protection from radiation and extreme temperatures, allowing settlers to live and work in relative safety. At first, frequent supply missions from Earth will be necessary to provide food, tools, and spare parts. But in the long run, survival depends on self-sufficiency. Every resource must be carefully managed. Food production will be one of the most critical challenges. Hydroponic farms and underground greenhouses will provide fresh vegetables, while scientists experiment with genetically modified crops that can thrive in Martian soil. Could lab-grown meat become a staple of Martian diets? The answer may define the future of space agriculture. Every drop of water, every breath of oxygen, and every ounce of material must be recycled. Waste will be repurposed, air will be scrubbed and reused, and water will be extracted from underground ice. Nothing can go to waste. Step by step, Mars will become more than just a research station. It will be a home, a place where humans live, work, and dream of the future. A place where the first generation of Martian-born humans may one day look up at the sky and wonder about the distant world their ancestors once called home. But this is only the beginning. In the coming decades, Mars could host thriving cities, connected by underground tunnels, supported by industries mining Martian minerals. With advancements in technology, we may even terraform Mars, thickening its atmosphere and warming its climate to make it more Earth-like. However, terraforming is a process that could take centuries or even millennia, requiring advanced scientific breakthroughs in planetary engineering. Could Mars become humanity's second home? The first settlers will lay the foundation, but it will take generations to transform the red planet into a new world for humanity. And what about governance? As Mars develops, discussions will arise about laws, leadership, and how society should function on an entirely new world. The journey to Mars will be the greatest adventure in human history. It will challenge our technology, our willpower, and our very nature. But if we succeed, we will no longer be confined to Earth. We will be pioneers of the cosmos, taking our place among the stars. The red planet awaits. The journey has begun. The first footsteps will be historic, but what comes next will define the future of humanity.